So today we will go through this segment that's called call routing. So the call routing is really SIP calls that come in the system and are routed as decided by the routing engine to various destinations. Okay. So here I will give a routing overview, everything that can be done. Then I will explain each of these modules, like the internal routing, the routing scripts, the label routing, radius routing, and SIP redirect. So each of these elements can do routing in the system in different ways. So if you look at this diagram here, we have the SBC, which is represented by this bubble here. Then you have your incoming call, which comes from the service provider or a phone or any device connected to the system here. And then it's going to do some processing according to your needs. And in the end, it will make one or multiple outgoing calls here to other service providers, other phones, other PBX, other endpoints. All right. So you come in here with one call, and the outgoing call can be a list of possible destinations that can be reached. Each of those destinations can have different numbering scheme, different parameters in the SIP header. So it can all be different. When the call comes into the system, it goes through the routing scripts. All right. So every time the call comes in, it goes, it hits the routing scripts first. Even if you don't configure routing scripts, it will still use them. All right. So by default, when the call comes in, it hits the routing scripts and does specific functions. These specific functions are what we call the internal routing. All right. So the internal routing is our routing table that you can go in and input some sets of parameters to decide where the call can be routed and how they can be routed. Okay. So what you will get here is your incoming call comes to the routing scripts. If you don't do any modification to the system, it will go automatically to the internal routing here with incoming call information. So the information from the incoming call here will be extracted, and you will have some parameters that will be used by the internal routing here. Once this process has completed, it will return a list of possible routes, and these will be used to make the outgoing calls. All right, so the path is incoming call, goes through the routing scripts, go into your routing table, comes back with a list of routes, and goes out and tries to reach those destinations. The other thing that can be done is do routing scripts. So then when you receive the call and it goes to the routing scripts here, you can, instead of using the default internal routing table or other types of services, you can design your own routing script here. So this routing script can be doing all kinds of things. For example, we talked about it the first day, it's fraud detection. You can have a black list here. You can have a modification of called and calling number. You can have extraction of SIP headers or adding SIP headers into the SIP calls. In the end, normally, well, maybe the call will be refused, but most of the time it will try to make a call here on the outgoing leg with one or multiple valid destinations. All right, so the routing script is very flexible. It has parameters accessible in there that you can modify and choose what you want to do. Right? Some of these routing scripts are implemented by us, and you can just use those scripts as needed, or you can modify them to do exactly what you want. A third option is to use Radius as a authentication server. All right, so you will receive the call here, then you will send a Radius request to the Radius server. The Radius server will return a list of information, and most of the time it's a list of routes that is returned here. And this will be used to route the call here on the outgoing leg. All right? So instead of being the internal routing table that takes the decision, it is the external Radius server. The Radius server could also be only accept call or refuse call. So if it's only accept, so you will send the call to the Radius server here, and it will return accept or refuse the call. And we can use then the internal routing table or other routing scripts to do our calls. This Radius server is not provided by Telco Bridges. So it is provided by partners of Telco Bridges. So anyone who does a Radius server and can receive Radius requests is a potential partner for doing that type of application. So what we do here is when we receive the call, we will fill the Radius parameters inside the Radius request, send it out to the Radius server. Radius server usually has a database backend here that can search through this database for information about calls. For example, some have implemented least cost routing, or time of day routing, or all kinds of services. And so it's going to search through this database to choose the routes, and it will just send a Radius response with lists of information that can then be decoded by the SBC and sent to the outgoing leg. Another way that we have implemented is to use a SIP redirect server. Again, the call comes in to the routing scripts, and then we make a SIP call with either the incoming information or modified information in the routing scripts to the redirect server. Redirect server returns a 300 response, and in that 300 response, there will be a list of contexts that will be used to route the calls to the outgoing service provider. So you get the call in, the routing scripts will make a SIP call to the SIP redirect server. SIP redirect server takes the information and does least cost routing or any type of routing here, and will return the list of possible destinations. Now here it says list of contacts because it's the contact field in the SIP header, but it's actually just information that is being put in those 300 response that can be understood by the SBC and will be chosen to make some outgoing calls here. So maybe you have 3 contacts on 3 different networks, or it could be 3 trunk groups that it sends to the SBC, and then we can choose those trunk groups for outgoing calls. Again, the SIP redirect server here is not done by Telco Bridges, so it is provided by our partners, and and then we can just interface to them this way and do some external routing with a SIP redirect server. Any question on the overview? Yes. How much latency? Okay, so here the process, the way it works, if we just have this process here, we can, it's the latency is very short. Okay, so we can do depending on the server that is being used, maybe 600 calls per second or more. So the latency is very short, and it's a linear process here. When you do a radius request, then the way it works is that the routing script releases the radius request and waits for the answer. So the time it takes for the radius server to do his job and receive it, that will be the additional latency. In practice, what I have seen is it's around 100 milliseconds for getting the answer from the radius server. But depending on the complexity of the radius server implementation, it could be longer than that. So we really have to verify with the radius server. Once you receive the answer here, well, there's no latency to send it here. Right? So the latency is only in the communication here. And this is just one IP packet. So there's no latency sending this here or receiving the answer. The latency will be on the radius server. And it's exactly the same on the SIP server here. The latency, it depends on how fast the SIP redirect server can answer the call. Like I said, in practice, around 100 milliseconds for that. So normally it should not affect the post-dial delay. Okay, then you have, can SBC support the SIP registrar server? Check the register and return back SBCs on the call. Okay, so everything we have explained yesterday also works here. Okay, so you can have another here device here, a registrar, and when you get your call coming in and it finds out it's a registration request, then it's going to send it to the register and send it back out here, and then the phone can make a call into the system, and then we can go either radius, SIP redirect, internal routing, routing script, and then go out like this. Okay. James, did that answer your question? Okay. Can we load balance SIP calls among different NAPs? So, so you mean here on the outgoing leg or to the SIP redirect server? Well, okay, but both are possible anyway. So you can have multiple SIP redirect servers and you can load balance amongst them. And here you can also load balance. If you have multiple routes, you can load balance against multiple destinations here or prioritize them. For radius, right now we have only one radius server that we can access at any one time, but you can have a standby radius server being here waiting for takeover if there's a problem with this one. Okay, but it's this one we cannot load balance. Okay. So we'll explain that in more details anyway in the next slides. Now, here I start with the internal routing that we also call the routing table. That is in the route section of the configuration. So once you have all your NAPs, so yesterday we configured all the NAPs in the system, and then you will have all of those available to route calls in the system. Okay, so you have in this table three main segments. One is incoming call attributes, one is outgoing attributes, and one is custom attributes. All right, so for each of the routes that you give a name here, you can set parameters for called and calling, well, incoming called, incoming calling, and incoming NAP. If this is matched, then it will maybe, depending on what you have put here, remap the call number, remap the calling number, and send it to a different network access point. And then you have custom attributes. Some of them are always there, like priority and wait, but there are, you can add more in some situation, which I will show you. And here you can have many routes in the system. Okay, so here we show like 7 routes, but you can have hundreds or thousands of routes in the system. And before I forget, because it's not in a presentation, when you manipulate these routes in this section of the web portal, you can do it one by one like this, or you can download the all the routing table in a CSV file and modify the parameters there and then reload it into the system. So this can help you to make it quicker sometimes if you have a lot of routes you need to do. Okay, so I will show you that. Gateway CSV. Okay. So if you look at the incoming attributes, you see you have called and calling number. You have 3 things you can do here. First is leave it empty. So something like this, if it's empty, that means any number will match. Any incoming call that has any number, any calling number will match this route. So this means we won't check the calling number in these cases. You can have also a specific number. So for example, 1-800-932-4567. If that exactly that number matches, then this route will be able to be chosen. Okay. Most likely doing this is it's for testing. So usually you put just one number for testing a specific route to a specific destination, and you will use this. Okay. Then you have regular expressions. So a regular expression will dynamically match numbers. So you can have a regular expression like this one, and this one in particular will match any call number that starts with 771. Okay, so I will show you some regex later. Then the last part of the incoming attribute is the network access point. If you put any network access point will match, or a specific NAP. Okay, so if normally you specify a NAP here, so that means only calls coming from this network access point will be able to be routed. But if you leave it to any, then any type of call can be using this route. Okay, so usually you put any when it's like a default route, meaning that if it doesn't hit any other route, it's going to go to this particular destination. The next part of the table is the outgoing attributes. So the same thing, when you have you can have multiple possibilities for the remapped. If it's empty, like this one here, that means you keep the incoming call number. So the call number will not change from the incoming leg to the outgoing leg. You can overwrite the number completely. So that means discard the call number that you have there and replace it with another number. Like in this case, whatever call that will have matched this specific entry will be remapped to 781. Okay. The third possibility is to have a post-routing translation, another regex here. And so you need to do something like this. And for example, this means remove the 771 prefix. All right, so this is a common application of prefix routing. Then here you have the remap NAP. All right, so that means where this call will go to. So here I have NAP level 3, NAP soft phone, NAP bell. So depending on which route it has chosen, the outgoing call will go to this one. The other option you have here for remap NAP is by registered user. And this I showed you yesterday in the SIP registration training. If a phone is registered and you want to send a call to that SIP phone, you need to set at least one remapped NAP as by registered user, meaning it will be able to be reached. Okay. So here I give some examples of the routing table. So you have, for example, the incoming network access point here and various outgoing network access point. Here you see I have put my outgoing network access points here in my route. So if I get an incoming call which has the calling number matching this one here, 450-655-8993, then since it comes from the NAP in here and it has the calling number that matches, no call number verification, it will go to NAP A. Okay. So the call will go here to NAP A. If you get a call from NAP in and you see here the calling number does not match, so this route will not be selected. The call number matches here, so then route B will be chosen in this case. Okay. And here you see the number is still there, but it's preceded with 1-800, so it will not match in this case because this is a single number matching. Here I have another routing table and I just have 3 routes like this: in 1 to A, in 2 to B, and in 3 to C. So this is a one-to-one mapping. So if a call comes in from NAP in 2, it will go to NAP B. If it comes from 1, it's going to go to A, 3 is going to go to C. So you can do direct mapping like this. Okay. You can also have route retry. So that means when you get a call in like this from this NAP and there's multiple matching conditions. So here I have 3 matching conditions and I have 3 possible destinations for the same conditions. So that means by default, the system will try to reach one of these NAPs. And right now you don't know the order in which they will be chosen. So it could be NAP A first. If that call is not successful, then it's going to try another possible destination. And if that call is not successful, it's going to try another destination. Okay. Now, if I come back here and I just put information like this in the table without priority and wait information, then I don't know which one will be chosen first. Is it A, B, C, and in what order? I have no idea. So to make sure you do the right thing, you need to set the priority and the wait parameters. So the priority parameter will be the lowest value will be chosen first. So in this case, it means that if I get a call from NAP in, I will choose NAP A or NAP C first because it has the lowest value here. And if A and C are not available, then I will use NAP B. So that's why here we call it backup NAP. So only if these A and C are not available will it go to B. Then since those two have the same priority, which one will it choose first? Well, you can decide with the wait value to balance how your call will be distributed between the two network access points. So this is load sharing. If you put the same value here and here, you will have 50% of the calls on both. But for example, if you put 100 here and you keep 50 here, then you will have twice as many calls here than here. So you will have 66% of the calls going here and 33% of the calls going here. Right? Now, when you make calls to the system, you may have one call going here, another call going here, and then a third call going here on the NAPC. But it doesn't necessarily have to be like that. So it's possible that you receive 3 calls here before you get one call here, and maybe the next call will also be here. But over time, you will have 66% of the calls here and 33% of the call here. Now, these route retry settings can be configured. So the default configuration of the system is that the it will try to reach a destination, and if there is no alerting, okay, so alerting is either 180 or 183. If there's no alerting inside of 10 seconds, it's gonna go to the next route. All right, and the next route, same thing. If there's no 180 or 183 for 10 seconds, it's gonna go to the next route. All right, you can change this timeout just by going here, and instead of waiting 10 seconds, maybe you want to wait 15 seconds or 20 seconds or more. All right, so you can change this, and you can change the state of where the timeout is canceled. All right, so sometimes you can use just call accepted. Call accepted is the 100 trying. Okay, so 100 trying here. If you receive the 100 trying, you can cancel the route retry timeout. So that means you receive the 100 and it's okay. We won't try the other route right now. Okay, we won't use this timeout to try the other route. And some customers also go all the way to call answered. So if you maybe you put 20 seconds here, and you put call answered. So that means if there was no no, sorry, they put 20 seconds and call alerted here. So that means it's gonna wait 20 seconds before it gets the 180. And if it puts call answers, then if the call is between 20 seconds, then it's also gonna switch to the other route. Okay? So you can configure all of these parameters. Now, these are in the gateway configuration and in advanced parameters, and this applies to all the system. In addition to these settings, you can also configure per type of errors. All right? So if we send a call to one destination and it returns us some values like a 606 or other types of values, okay? You can decide to have it stop the call or continue the call. All right? So that means if you receive a 604 from the destination, you will stop the call. If you receive a 603 here, you will continue the call. Right. If you receive a 606, it's going to be this one that will be chosen, right? And here we will continue the call. If we receive a 600, it's going to be stop call here. Right? This will be what we saw yesterday, the converted reason cause mapping for the incoming leg. Right? So if you have 3 possible routes, the first route returns you 603, you will try the second route. If the second route returns a 604, you will stop there. You will not try the next route. All right? All of these can be modified in the system for each type of error you get. So some of them are by default, like these ones are all by default. And you have, here you see I have changed some configuration here. So maybe I have changed the route retry action, or the reason cause mapping. Is that clear? Okay. Now, just a few notes on the regular expressions. I explained this because it's being used a lot by our customers, and a lot of them are not so familiar with regular expression, and they're always like, oh, it's complicated. However, here I just do a little introduction, and you will see for manipulating digits, it's pretty straightforward. And with a limited set of examples, you can do 90% or more of everything you will ever want to do on this type of system. So let me explain just a few things. You have the demarcation, which are front slashes. So you will always get front slashes for your definition of your regular expression. Then you have here the caret, or the little hat here, which means start at the beginning of the number. All right, so that means if you have a called number, start with the first one, because you don't necessarily want to match anywhere in that number. You want to start with the first digit. So almost all the regular expression has this symbol put in the regular expression. And end of digit, so that means go all the way to the end before accepting this regular expression. Okay. You have in regex, you have something like this, a dot, which means any characters. Any characters includes numbers, the plus sign, letters, and stuff like that. But most of the time, when we work with these types of systems, it's only digits. So instead of using a dot, which is any character, you will use, you can use something like this, the square brackets, and then just put digits. So you can put something like this, 0, 1, 2, 3, up to 9. So that means choose any one of those digits. And here is the same, 0 to 9. So any digit from 0 to 9, that means one digit in that group. Okay. So these two are the same. So why would we want to use one or the other? Is maybe here you don't want to use the 0. Okay, so you would say 1 to 9. You can do 1 to 9 here as well. Okay, but let's say if you don't want to use the 4, then it's a bit more tricky to do this. Okay. So this is one way to do it. Let me just go back here on the right. It's a number of occurrences. All right, so if you follow something with those curly brackets, then you can say how many of those occurrences you want. Here it's one digit, and here it's 5 times one digit. So that's 5 digits. All right. Here it's another example, 1 to 3 digits. All right. So only if there's 1 to 3 digit will this regular expression match. If you don't know how many digits you will have, you can just put a star like this, and that means any number of occurrence. Or if you put the plus, at least one occurrence. Okay, so the two of them are pretty similar. Other values you can use, the interrogation mark means optional. So that means optional digit. Or like this, so you can have values. Here it says 1 or 2, but you can put like 450 or 514. All right, so you can put two different groups of digits here. Not is not used very much, but it's just shown here. And then in the remapping, we use these 3 values here on the left side. You select a group, and then you can say \1 for the first group, \2 for the second group, \3 for the third group. So each of these groups will be defined here. All right. So let me show you some examples of regular expressions. So you have, and these are very standard, the ones we see normally. So you start with this front slash here. and you end with the backslash here. All right, so you have the front slash here, the backslash here. That just means this is my regular expression. Then you have your start of digit and end of digit. So pretty much, if you see this, you can disregard those information. That means I want to work on all my digit string. Then you have what you want to match here. This is a optional one. So one, the value one, and is it present or not? It doesn't matter. The three other digits need to be 450. And then here it's one digit repeated 7 times, or 7 digits that you can have here. So optional one, 450, and 7 digits. The other example here, so again, you can disregard these parameters here. This is 450 or 514 and any number of digits. So it is in fact match on 450 or 514 prefix. Here you have start with optional plus. Okay, so again, you have the same characters at the beginning and the end that you can disregard. And then here you have the plus and optional. However, since the plus is a reserved character in the regular expression, you need to put a backslash in front to say, this is not a reserved character, it's a normal plus. That's what I want to see here. So optional plus, and then any number of digits. The parentheses here are only for selecting groups, and you can disregard them in this case. When you want to test your regular expression, you can use some online tools. And one of them that I use often is called Rubular. So you just go to this site here. What you do is you put your regular expression in the box here, and you see there is a front slash here and a front slash here. So you don't need to put them in the regular expression. And here you can put the values or the regular expression itself. And this you can put all the test values you want to try. Okay, and here on the right side, it's going to show you which one has matched this regular expression. You see here, the first one matched because it starts with 450. Okay, here it starts with 450. And the second one matched because it starts with 514. And the third one did not match because it starts with 613. And 613 is not part of this regular expression. In addition to this, since I have put some parentheses here, 1 parenthesis and 2 here, that means there are 2 groups. So this is group number 1. This is group number 2. So here, when we match the group number 1, it will say group number 1 is 450, and group number 2 is the rest of the digits here, the 7 other digits in the called or calling number. Okay. And then you have a match 2, and you have the same thing, 514 in this case, and here. Why do you want to do match groups? It's for regular expression remapping, which I will show you here. All right. So in this case, you have a first group that is 450 and a second group, which is 7 digits. And here we say replace everything that is here with a specific number. So that's just replacing with this value. You can have something like this. First group, 450. Second group, 7 digits. And here it says keep only the second group. So that means when you receive the call, the number must start with 450 and have 7 digits after this. However, when we replace, we remove the 450, we keep only the 7 digits that are available here. There's another example here, which is replace 450 with 514. So you have the 450 prefix here, and that's the first group. The second group is here. So then we will keep only the 7 digits, and we will prefix it with 514. So it's just replacing the prefix. This one is a bit more tricky. It means remove the plus 88 if it exists, because you have a interrogation mark here. And in front of any number and of characters, so you can have here any characters in the end. So sometimes we use this dot star for domain names or something like that. So you can reference this for examples. Okay. There are also other examples that are in the presentation, which I will not explain here, but you can look them up if you need to do some of these functionalities. Okay. Now, on the wiki, on the TB wiki, there are some examples there as well. And if you follow this guide, follow on the wiki, you try with your ruler and you still can't make it work, then no worries, we'll be there to help you to do your regular expression that you need to do, okay? Any questions on regular expressions? Okay. Now, I showed you that you can test your regular expression with the tool online. With the tool online. And then you can also test in the system. So when you create your routes, your static route table, and you put a regex there, you can, before you activate the configuration, test it. All right. So what you do is you go in the routing script section, and if you go a bit down, you will see it says here testing script, but that it's also testing the routing table. Okay. And when you, okay, so what you can do here, testing script, is simulate an incoming call. So you can simulate what you receive as a calling number, as a call number, as a network access point, or the source of the call is this network access point. And you can add all kinds of other parameters here. When I will show you the routing scripts, I will show you the parameters that are available, and any of those parameters can be put here to simulate what will be received in your system. Now, okay, so first you input all your parameters here, then you press on test, and it's going to give you these information. Okay, so which routes have been matched? Okay, so number 1, number 2, number 3. So you will have the order of how the calls will be sent. So the first call that goes out from the system will be using this route name in priority. And I can see here that it's being sent to the NAP soft phone. And here is what is in the routing table, but here is the called and calling number that will be used for the outgoing call. And you see, for example, the second route here. Well, the first route is a regular expression on the call number. Okay, and the second route here has a remapped calling of 781. So we replace the calling number. And we also remap the call number to be starting with 666 instead of 800. All right, so you see here it starts with 666 instead of the 800 that we received the call. Of course, these are just examples of what can be done, but it's very interesting to see which routes will be taken in the system before applying the configuration. All right, so like I said, you can input your routes, put your regular expression, and just do a test here. and you will see if the information that you are expecting to see is what you see here. If there's any error in the regular expression or something, well, it won't work here. You will see either errors or strange values or no values at all, depending on which error you have done. Here, this NAP list table is handled automatically. So every time you add a new network access point, it will be added there automatically. If for some reason you don't have all the NAPs that you have configured in the system, you can just press on reset here. It's gonna rebuild this NAP list table for you, okay? You can simulate also status of network access point. So by default, the availability is 100%, but you can change it to 0, for example, to say that this NAP is not available anymore. So for example, if we here by default, the soft phone is the first route that is taken, but you want to simulate that the soft phone is down, you can change here the value of NAP soft phone to 0 here, and then it won't be chosen as a route, right? Because it's not available, and the system knows that if the NAP is not available, it's going to try other destinations. All right. So for the internal routing, how you can debug, well, most likely, most of the cases are handled by the call trace. So you just look at the call trace tool, which will go more in details tomorrow. But it's very easy, right? You just look at it, you see the call coming in, you see which called and calling number were used, which NAP, and then you can see where it's going out, which route it's trying, and you can have most of the information here. If you cannot find the problem with the call trace, well, you can look at the signaling trace as well, which I showed you briefly yesterday, but I will show tomorrow how to do that. You can look in the NAP status. So the NAP status will give you reason, cause that you have seen, how many calls were answered, terminated, if the NAP is up. So you'll get information on the network access points. CDRs, call detail record, will also have all the information about the calls that came in and out of the system. So you can study the CDR to see if your calls are going where you expect them to be going. If you can't find your answers with this, well, in gateway application, if you go at trace level 1, you can see every single step that this application is taken to route the call. So you will see which routes have been chosen, which parameters are incoming in the system, and then which route has been chosen outgoing. And so you can see all the details in these specific logs. And like I said just a minute ago, you can use the simulated route testing to see what is going on and is it what you expect it to be. Okay, so that's the overview of the internal routing. So you have the routing table, you can manipulate the values in there, and this will have it will create a list of routes or lists of possible destinations, and then the system with the route retry will try to reach each one of those destinations, and as soon as one succeeds, it will stop the route retry, and then the call will proceed. Questions on internal routing and the routing tables? Okay. No questions. Very good. So next step. If this routing table that we have shown here with the regex and the remapping of numbers and stuff like that is not enough for your application, we can add more functions to this. All right? So to do this, we have to use the routing scripts, and it complements the basic routing or the internal routing. It is not replacing it necessarily. All right? So you can use the routing script to do one functionality and then do your internal routing. Or you can do the internal routing and the output of that can be modified to do something else. In those routing script, you can modify any script available parameters. So you have a list of parameters that are available to you in the scripts, which are the basic one are called calling and privacy and private address, the domain and stuff like that. So you have all these parameters available in the script and you can modify them. And you can also create algorithms. You can do some conditions for various type of applications. And then you can use some of these ready-made scripts, which we have done, and we can add those to existing scripts. So we can just add the portion of the script so that it can do one function, and then you have the other function and another function. Each one can do different things. So let me go more in details here. The an SBC call will come in. Well, okay, so initially when the call comes in, it comes in at the TB router application. So yesterday I showed you how to capture a PCAP trace with TB router. All right, so the call comes in here in this application. If it goes through this SBC function and it's accepted, then it will be passed to the SIP application, or if you look in the system, it's called TB SIP. And then if the SIP accepts the call, it will send that to our engine system. The engine will then send the call to the gateway application. All the routing script and internal routing is done in the gateway application. All right, so the rest of the path is only for forwarding the SIP call, but the rest of the work is done here in the gateway application. And that's why I said just before, to see the internal routing logs, you have to set this application gateway to trace level 1. So the call comes in gateway, and it is shown as an incoming call leg in gateway. So you will most likely have an incoming call leg and an outgoing call leg for each of the call that comes into the system. This incoming call leg comes in with a set of call parameters. So these call parameters are the ones from the routing script parameters that I will show you soon. So these call parameters come into the system, and the standard internal routing will do two things. One is route match. Route match, as you remember in the routing table, there's two portions, incoming call attributes and remapped call attributes or outgoing call attributes. So the incoming ones are managed by route match, and the remapping or the outgoing call parameters is managed by the route remap. So what you do is you take the incoming information. Does it match this route? If so, then it's going to do the route remap, and it's going to send the call to the outgoing call leg. So when you receive the call, it goes to these three steps, and then and the outgoing leg, you will have a list of routes, maybe just one, maybe zero, maybe just one, or multiple ones. Each of these routes can have different call parameters for each of the routes. Okay. If you add to this a routing script, what it does, it's going to modify the default behavior of the system. And you can add information or modifications to the regular routing in 3 places. Before filter, so that will be before matching the routes. After filter, that means right after we have matched the routes. And you can do it after all the routes have been selected and created. You can modify these routes before sending them out. As I said, the incoming parameters, and that's examples, right? Calling and incoming NAP, but you have a list here of call parameters that you receive. The before filter can then modify those call parameters, right? So one before filter that we have is the black-white listing. So maybe this calling number you don't want to get in your system. So you create a before filter and you say black-white listing, this number, and the call will not even go through the rest of the process. It will be dropped right away. So, but you can do all kinds of things with before filter, like normalization of numbers. You can do pre-filtering. You can do all kinds of things here. When you get out of this before filter, you still have these call parameters, but most likely they will have been modified, right? Because the before filter will have acted upon those call parameters to change the behavior of what you receive in the system. Then here, you will match those call parameters like we do usually from the routing table. You can then do an after filter. So when you get out of this route match, you still have your call parameters, but you also now have routes that have been matched and that are possible destination for the system. And you have one additional set of parameters, which is called bridge parameter, which I will talk to you in a few minutes. So you get now 3 sets of parameters here. You can do a route remap function. So that is from the routing table. The second portion of that table, what does it do? Okay. Then you just configure that from the web interface. And in the end, and then there's one more set of parameters that will appear, out call parameters. So these are parameters that adjust to each one of those routes. Okay. And then you can do an after remap filter to modify before sending the call to the system. Okay. So the way it works, you receive the call in here, you process the information, and you send the rest of the information to the system here, and it will do the rest of the process for call routing. All right, so go through each of these routes one by one. Okay. Is that clear? Okay. So it gives you, yes, it gives you a very a flexible way of modifying the information that you get for your routing. So just to review here, before filter, it modifies incoming parameters. Route match will be used from the static routing table, and it will be used to create possible routes in the system. If you use an after filter, it's going to modify all those matched results. So those routes that were created, you can modify them. Route remap will then be used. So that's the second portion of the static routing table. and it will be applied to each of the routes that have matched before. And in the end, you will have a after remap filter that can modify the final routes, the final call parameters just before being sent on the line. The incoming call parameters are here, call, calling, incoming nap, but let me show you the list of numbers. I'm sorry, the list of parameters. So they are here. It's in the, the link is below here. Unfortunately, I don't know why I don't see it, but it is a mini development guide. So if you search for that on the wiki, you will see all the information that is present in the routing script and what does it match to in SIP. Okay, so the from field, the user part of the from field will be the calling information. The host or domain in the from will be calling SIP host. So these parameters can be used in the script, and if you modify them, it will modify the domain, the user info, the port that you are using for making these calls. Okay. For example, the display, calling display, the display name of the from can be manipulated with this parameter. You have p-asserted IDs, calling party categories that you can use here. You have p-preferred identity, user info, port number, diversion. So all of these are available, and you have lists of those parameters that you can use here. Okay? Each one of them are explained if you go down this page. Okay? So the list is pretty long. In addition to the ones I just showed there, there's also SIP headers, right, that can be extracted, additional SIP headers and stuff like that. So you have the incoming call parameters, you have the routes, which are all the possible destinations for your calls. And here you have also bridge information, which describes additional call flow information or modification from the standard call flow. And here I have three examples. One is an announcement tone. So that would be, if you have a bridge parameter called announcement tone, then it says play an audio file on the incoming call before any outgoing call is placed. All right. So what happens is you receive the call. Before you make the outgoing call, you will play a message to the caller. Once that message is done, then you will make an outgoing call to the destination. If you do a bridge parameter, but with ringtone, then the audio file is played on the incoming leg while waiting for the other one to answer. So that's a regular ring back tone function. Then another one that is being used is max call duration, and the call will be dropped after this duration. So one way that this is used is for a prepaid service. So for example, we receive a call, we send that out to the radio server. Radio server says, yes, I accept this call, but only for 10 minutes. So we receive the answer and we will set this value, max call duration of 10 minutes in the call. After 10 minutes, the call will be dropped and you can send a specific termination cause, and you can also play a specific file if you want. Right? So there's other parameters you can set here. To play a file, you need to have the transcoding device, of course. And then you have also the out call parameters. So these are the same as the incoming call parameters, except you have them for each of the routes in the system. And it can only be used in the after remap filter because it doesn't exist before. All right, so then you have a series of parameters for each of the routes, and you can manipulate these if you need to. Okay. So this is how to work with the routing script, or what is possible with the routing scripts. And we have built some examples over time. Most of the time, this is a request coming from a specific customers that says, I want to do this function, right? And then we discuss together and we figure out, well, this script doesn't exist in our system, so we can create one. And over time, we have created some of these routing scripts. One is called black-white listing, and it is used to block specific numbers or let some of these numbers pass. You have the script that's called pre-remap. So this is made to normalize numbers before reaching the routing table. So for example, you receive a call which can have a prefix. And sometimes it doesn't have a prefix, right? And you don't care about this prefix. So you can say, well, if this prefix is there, I'll just chop it off. So you can do this before you hit the routing table. Otherwise, you will need to create two routes, one with the prefix and one without the prefix, or you would have to do a regular expression for each of these routes. Okay, so there's a simplification that can be done with applications like these ones. Then you have another one that's called add custom CDR. So this has been requested again by customer. So what this script does is that you receive a SIP call in the system, and then you have a private SIP header in there. So maybe it's called the X-CDR. That's the SIP header that is there. And what we can do in the script is extract the data that is in this XCDR parameter and put it in the call detail records for this specific call. So then the billing system can recognize that these calls are coming from this specific source. So this, we have used this at many places. Then we have a SIP header manipulation. So we can here, as an example, remove a SIP header, add a SIP header, modify a SIP header. So you can play with this in the script. And we have a list of scripts. Some of them are available in the web interface. However, not all of them are available there. Others are available on the wiki. So you can find them on the wiki, and they are described there. You have the .rb file, and RB file is a Ruby format. It's a script in a Ruby format, okay, using Ruby functions to process the information. And so these are either on the wiki, already in the SBC, but in our support group, sometimes we do other scripts that don't make it in the web interface, or we don't have time to document them on the wiki. So we have them available just internally, okay? So one way to do this, and so that you don't waste any time, is first verify if a script that you would want to use already exists, either on the system or on the wiki. And if you can't find it, then you can just ask us, right? I'm trying to do this particular function. Do you have this script available? If we do, We'll package it and send it to you and say, this is how you install it, and go ahead, you can use this script. It's also possible that you tell us, do you have this functionality? We say, yes, but not exactly. So then in that case, we can show you what we have done. If you have someone that can do Ruby scripting or programming, he can go and just modify it. So we have some customers that are very familiar with Ruby and they just change what they want. But also a lot of our customers do not know the programming of Ruby, and they prefer come to us and say, well, this script does maybe 80% of what I want to do, but not the last 20%. So then what we will do is propose you some professional services that we can spend some time to do what you want with that script. Okay. Of course, it has to be something that is doable. Okay, so we will verify with you if we think it's workable, and it has to be let's say feasible by the support team. Otherwise, if you need to have more and the support team says it doesn't have the expertise to do this level of complexity in a script, then we may have to involve our development group to work on a script for you. Okay. So if you, I put a link here. If you go here, it will show you how to activate these scripts. So you have all the information. Here is the script. You go here, you set those values, okay? And what I did here is I gave one example. And one that is easy to understand is black-white listing file example. So first, what you will do is you will go here in routing scripts. That's where you will enable this routing script. Oh, sorry, let me start with the beginning here. First thing is to create this file, because the black-white listing is just a CSV file. It's just parameters that you put in, and you may want to block some calling numbers, or you want to block some called numbers. So you just create a CSV file like this with only 4 columns, calling parameters. So you have just 2 choices here, black or white, and then called and called parameters. Okay. So you build this black-white listing file. You need to name it this name, okay? By default, it's gonna use absolutely black_white_list.csv. Okay. Then you need to go here in FileDB and upload or import a new file in the system. All right, so this file will be uploaded in the configuration of the system. If you need to modify the file later, all right, 2 choices. You can just add more lines in this file and update it. Or you can first export the file, then you'll get this file, modify it, then update it. So you'll get the new version of this file here. So first, create the file. Second, import it in the system. Third, go in routing script section. Choose the main script of your system. So by default, it's called simple routing SBC. You choose the main script of your system. You need to add 3 lines in the main script. At the beginning of the file, you add this, exactly this line. After the class section, you add exactly this line. And after all the includes, you can add the before filter method, black-white listing. It will give something like this. require base routing, which is always there. Then you have require black-white listing. It's possible that you have other require here, depending if you're doing more stuff in the routing script. Just after the class, you will have include black-white listing. Here it's very important to follow the formatting. So capital letter here, here, and here. And it's all the naming convention is very important. If you make any mistake here in this line, when you try to activate or validate the configuration, it's going to give you an error. It's say, hey, this doesn't exist, right? Then you will need to put the before filter method here. Okay. Let me just show you quickly what it looks like in a web interface. So I go here in routing script. So you have something like this: require, include, and before filter. So here you see I have other before filters. So if I want to add the black-white listing script to this particular main filter, main script, okay, I can go here and add this line here that's called before filter method black-white listing. I can add it here. And you have to make sure it's done at the right place. Because, for example, this function does something, this function does something, and then black-white listing does something. So maybe you want to do black-white listing before all these methods, or you want to do them after. So the order in which you put them here is important. Okay. It is also important to have just one main script where all the functions will be called. So you see the route matching and other functions present here, and they will be called in order here. Now, in the specifically for black-white listing, the programmers have added one more parameter. You see the last one here, the scope. Here it says scope global. If you put global, it applies to all calls. So you load one file, a black-white list file, and this will apply to all the incoming calls in the system. But they have added a new element that's called per-nap. So if you select, instead of global, you select per-nap, you need to add a new nap column that is called black-white list. The type attribute has to be DB file. And the default will be one of those CSV files that you have put in the system. All right, so black-white list.csv. All right. And now the difference is that you need to go and for each of these network access points, select which black-white listing file will be attached to this particular network access point. All right, so for each of the incoming network access point, you can have a different set of numbers that you are blocking in the system. Okay, so let me just show you this. So you can go here in nap columns. So just below routing script. Oh, I already have it here. So black-white list. All right, so you can do create new nap column, but here I already have it. So I can just click here. All right, so the name has to be black_white_list. So the naming convention here is important. The file attribute, you see I have all kinds of choices here, text, integer, Boolean, a choice, a nap, a profile, but here I choose DB file because it's a file that was loaded in the system. Okay, so I can see here, if I look in my file DB, I should see this file. I see this file here, digit map, ProSBC. I don't know why. I think it was just for testing. I put this here. Okay, so digit map file. So that's a CSV file. Maybe I can export it here. This is a digit map file. It's not a black white listing file. Okay, so bad example. And then if I go back to the nap columns, then I can hear for each of the naps, if I go, let's say for nap VMA1, I can choose the digit map ProSBC and can be different per network access point. Okay. Yeah, it was just for testing. I put this here. Okay. Is that clear how to do this? Oh, can we add numbers in list via API? Okay, so you can with the RESTful API. Okay, when we talk about the API, it's the RESTful API, which we'll talk about tomorrow a little bit. You can set network access point completely. All the settings that you can do here are it's possible to do that. It's possible to change here the file that is pointed by a napsip A4, so you can choose the file here. It is also possible to update a file here with the RESTful API. Okay, so you can do your RESTful API command, make sure you point to the right file in the system, and just upload the file raw here. Okay, so it is possible to do that. And let me try to remember to show this tomorrow. Okay. Okay. And the other thing I didn't want to forget here is in the gateway or the route, sorry, where you have all your routes. Well, here I have only one route. Let me take another system. This is the same system. Okay, I have, for example, here 1, 2, 3, 4, 5, 6, 7 routes, and you can do here export static routes. All right, so this all these routes here will be just dumped into a file which is not showing up. Yes, it is. It's here. Okay, so if I look at my table here, if I go down a little bit, so I have test route retry, calling is empty, and then the incoming nap, remapped nap is this one here, and then in trunk is value 9, priority is value 100, or oh yeah, it's not shown because it's the default value here, but anything that is not the default here will be shown in the list. Okay. Now, you will have in your system priority and wait, but you may not have in trunk or privacy, because these are other scripts that we have done for other customers. And if privacy is not verified in the script, it won't be recognized. Okay. In addition to this, and you have route attributes. So you can say here, create new route column, like in trunk here is a new route column. And you can go in nap columns, and you can do create new nap column. Okay, so in nap columns, those are parameters that are attached to a network access point. If you go in routes, these are parameters that are attached to a specific route in the system. So depending on what you want to do, maybe it's better to set it into the nap columns, or maybe it's better to set it in the route columns. All right, so when we decide on the script we want to use, we have to decide where we set those values. Clear? Now, the advantage of doing it this way, is that it's very flexible. The disadvantage is that you have to really know all your requirements before you start taking or using a script, because you need to make sure you cover all your requirements in those scripts. Is there any route failover? So Adam is asking that. There in all the system, there's always route retry or route failover being done in the system. It's always enabled by default. Okay? It is possible to disable it, but by default, it's always enabled. Okay. Here, there's two examples of SIP header manipulation. One is add the user equal phone in some call parameters. And this is already integrated. So you can just do these three lines in your script. Require SIP header params, include SIP header params, and then you set your after, and this is an after remap filter method. Okay, and there it says, just the formatting here is a standard one, but it says add user phone to user parameters. So it's going to add two, something like this, right? User phone to the to field. And this is the other example, is add trunk group name. So maybe you want to use this on the outgoing side. So then you need to add in a script, okay, this line. So for example, this is in the contact. Okay, so you want to add a trunk group value in the contact. So you say call contact parameters is trunk group, and this is the information I want to put in the trunk group. You just have to make sure that the route parameter forward SIP domain is set to 1. Okay, so these are things that are possible, and we can help you to do that if you have trouble with setting those parameters. All right, understood. Now, one of the scripts that we have done is called label routing, or sometime in the documentation, you can see route set routing. And this script was made specifically to route millions of numbers to a set of destinations. All right? So this is used usually when you have a lot of routes in your system, and each of the routes can only select some of these numbers, and you can't do a regular expression. Each of the numbers go different destination. So you could do it in the static routing table, but it would become very, very big. So you can, instead of using the routing table, use this label routing scheme. So what you do is you import your numbers in that have been input in a file. That file will have all the possible numbers, and it works also on the longest match. So you can have just a prefix for sets of numbers. And it will find the longest match for any called number that comes in the system. And it will give you one label. All right, so any called number that comes in will go through the list, and as soon as it finds the number, the longest match, it will give you the label. Then as a second step, you can tell the system which NAP can route this label. Okay, so all routes that have this label are eligible to route the call. So maybe you have 3 NAPs that can route this particular label. So this call number that came in will be able to route with 3 different network access points as destination. Okay. So here, let me try to explain this more in details. You have list of numbers. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 4, 4, 5, 6, 7, 8. So any number that starts with 4, 4, 4 and anything here, or 5, 6, 7, 7, 8 and anything here, or the full number here, all of them, if you receive this call, you will tag it as label 1. And these numbers here will be tagged as label 2. All right, and then you have lists of number. Of course, you can have, like I said, millions of numbers. So you can have a very large list of number. Once you find your label here, you will then have a second information, which means which NAP can route this label. So you have NAP A here that can route label 1, NAP B that can route label 1, and NAP C that can route label 1. So all of these NAPs will be able to route these 3 numbers. Okay. However, label 2 is only routable by NAP B and NAP C. Okay, so these 3 sets of numbers will only be routable by NAP B or NAP C. And then these NAPs can route different sets of label. So here I put just names like label 1, 2, and 3, but for you, when you need to use this, it's very clear, right? So it's going to be customer A that will have this label, right? And then customer B will have this label. So you can name the labels according to your customers or your destinations, and this makes it very clear when you want to configure your system. So how do we do this? Is we create one file that we call a digit map file, and that digit map file includes all the numbers that can come into the system, and you will attach all the labels of all these numbers. This digit map file also works on the calling number. So instead of using the call number, you could also do the same thing with the calling number and attach it a label. So most of the time we use the call, but we have some customers who use the calling segment here. Then you have the route set definition file. You need to have one. Okay, so the digit map file, you have only one for the whole system. And then the route set digit map, the definition file, you have one per network access point. So for each of those network access points, we inform of which label can be routed. So here, this example is route set definition file for nap A is label 1, label 6, and label 10. So any number that has label 1 will be routable here, but not the ones which have label 2. And normally we assign that file to just one network access point. And you can add other parameters to this route set file, and I will show you an example here. You have in your route set definition file which labels you can route. But in addition to this, you can put any parameter that exists in the routing table. And for example, you have priority, you have wait, and you have remap called. All these exist in the routing table. Okay? So you can use these values here to do priority routing and load sharing. All right? So if you receive a call which has label 1, any NAP which can route label 1 will then be verified with the priority, the relative priority between the NAPs, and will be routed. So for example, here, NAP A has label 1 and set priority 10, but let's say NAP B has also label 1, but be priority 1. So it will have higher priority. It will go out to NAP B before trying to go out to NAP A. Then you can do a remap called, and you can set either a regex or any other examples I've given you this morning. So for example, here, we will remove the 3 first digits. And here we will remove the first digit. All right, so it can be different per label that you use here per network access point. Okay. So to enable label routing, what we will do, all right, you need to go here in FileDB and import a new definition file, route set definition. So there's a specific segment in the FileDB that we can go, and it's called import new definition. Then you can add for each network access point you have in the system a new definition file, NAP A, NAP B, NAP C, or anything like that. So you just enter all your definition files that were created before, which have the labels, the priority, the weight, and the remapped values and stuff like that. You also enter your digit map file here. Import your new digit map file. And normally, most of the cases, what we see is there's only one digit map file per system, complete system, so that you only need to update one list of number, and that defines the labels. However, in some cases, you can also have a different digit map file per network access point. Then what you need to do is to, for each of the NAPs, assign the digit map file and the definition file. Right. So you just need to match the right name. And that's why here, usually we use the name of the network access point so that we can make sure we don't make any mistake here when we associate the network access point. All right. The only other thing you need to do after is to generate the routes. All right, so you click here on generate, and it will hash all those information so that when you get in the system and you have calls coming in, it will quickly find the destination label and the destination NAP. All right. So it speeds up the processing of the calls. All right. So this, if you have large files here and here, it can take a few seconds. However, when you are processing real time, then it's going to be very quick. For each of the call that come in, it finds right away the right destination. Okay. Once you have done here, generate a routing database, it will give you additional routes in the routing table. So you can go back to the routing table and you will see that there's new information that will have been created, and it will have your label name here being shown in the static routing table. Okay. And they're actually called dynamic routes here. Okay. Dynamic, not because they change, but because they were pre-generated in the system. You will also have a default name here that will have been selected in the system, but your label name will show here. When you use label routing, the incoming NAP is always any. That means I can receive a call from any source, and it will be verified. The number will be verified if it matches in our list, and the label matches, then it's going to be remapped to different destinations here. And you see, if you have set some custom attributes, they will be also displayed here. So in this case, both of these route sets have the same priority setting. Okay. So it's always from any source, and it's routed to one specific network access point. The things you cannot see here is the list of number. All right, so you cannot click on this route set and see all the numbers that are routed here. So you will have to rely on your digit map file to make sure it points to the right label in here. Otherwise, maybe some of the calls, if your digit map file is not set correctly, some of the calls will go to a different destination. Page 38. Okay. Is that clear, the label routing? Will anybody thinks he will use this? Don't know yet. I gave a training last February, and one of the participant there said, we use label routing in all of our installations, right? Because for him, it's very, very simple to configure this. The files can be uploaded at any time. And here I did not explain, but if only the digit map file changes, you don't need to do generate. Okay, the digit map file will be entered in the system and parsed automatically. It's only if you change the definition files here that you need to do generate and rebuild the hashing table. All right. And in the wiki, oops. In the wiki, it explains here what I just explained in the presentation. Okay. Here it says how long it takes to apply the configuration if you have 5 million entries or 500,000 entries. This was done a while ago, so maybe now it's faster than then. And then here it shows how to configure the label routing. So you just need to follow these steps here. All right. So for example, no. Here on this side, you need to add label routing to the script. You need to assign the files to the application. You need to add the digit map file to the system, add the definition file to the system, and assign them, generate the dynamic routes, and activate the configuration. So these are the steps. Well, I didn't show you the first one here. I can show you here from the web interface, but the rest of is what I went through in my example. And then once you have done this the first time, then the only thing you need to do is if you change the digit map file, then you need to update it. If you change the route set definition file, then you need to update it and generate the dynamic routes. And every time you do any of those changes, you need to activate the configuration. So if I open this up here, add label routing to the routing script, you need to go here in routing scripts, routing script, choose your main script as we said before, and then you need to add 3 lines, exactly like black white listing: require, include, and a before filter. All right. Here, the difference is that the method that we're using and the file that we're using is called route sets digit analyzer. You need to include exactly this file, and you need to put this before filter, and you see there's an additional parameter here that says what you want to use. And I showed you in the digit map file, you can use either the called or the calling number. So here you can choose called, calling, or called calling, okay, both of them. So you have three choices of how to do the hashing here. Okay. So this is an example of what it looks like once it's done. Whoops, that makes it a bit strange. Let me do it like this. So you add this line, you add this line, you add this line here, and that's it. Okay, so that's the full script that you are using. You just added 3 lines to the default script. Okay. Then if I go back here, then that's already done. That's digit map file, which I showed you how to do that. But here it gives you the example of a file, and then file DB, import new digit map, and then you have choose the file you want to import. That's it. Then you have void set definition files, the same thing. Assign the digit map files per nap. All right, so you just go in nap columns, CAS, or whatever nap you have, and you add route set definition, digit map file. Here, the example also includes black white listing, so you can still use this along with this route set definition files. Okay. And then generate dynamic route. I showed you, it's just a button that you need to press to generate. You just click on generate. Once you have set all your route set definition file and route set digit map files, just click on generate here. And the last is just to activate the configuration. So activate the configuration, go back in system here, and then you can validate it and activate it. Okay. Okay. So I see there's some questions that were answered. Are there any case studies on the best use of label routing? Yeah. Okay, I see what you mean. Yeah, for sure it exists probably in other platforms. We have two. ProSBC is easier to set up. Well, I have never done it on OpenSIPs and Camilio. So I don't know if it's easier, but I will take your word for it, James. If you say it's easier, good, good for you. Case studies for label routing. I don't think we have done specifically. William, do you have customers in your region that has used this, and you can give an example?
Yes, we have in Singapore.
Okay.
That they have done quite a bit of this. How do you want me to? How do you want?
Well,
example? What do you mean? Example is
well, just their environment, right? Why did they use label routing in their environment? Do you remember why?
Well, again, they have a lot of coded number. I mean, I think 1,000 of them, and then they need to simplify the routing. So they
right. So their routing table was too big, right?
Yeah. I mean, and then they have a lot of outgoing net to different destination, and that's why they set up this. I mean, they chose to set up this at the end. So it's simplify a lot. I mean, they have four or five route set definition files.
Yes.
And yeah, so different, no matter it's incoming or outgoing. Mm-hmm. So that's one example. I mean, mainly to simplify
the routing table.
Yeah. Routing, yeah.
Yeah.
Yeah. Exactly. They are one of the service. Kind of voice providers, SIP voice provider in Singapore, I think. Yeah.
Correct. Yeah. Okay. And you made me think of something. A lot of time when we do label routing, we use a default route. So if all these route sets or dynamic routes that have been created here don't match, usually we add another route in the system with a priority which is much lower than the rest, so that if the numbers cannot be routed anywhere, it's going to be sent to this other service. So this works as well. So label routing is made, and also the routing table is also these routes will be added to the possible destinations. Okay. And then we are using label and dynamic routing. Do number of lists in dynamic routing and label routing impact the call performance? No, it does not. So the only thing it affects is when you do generate, right? If you go here and you input all your definition files and routes digit map and you do generate, then it can take longer if the list of number is very large, or the list of route set definition files or labels is large. Okay, so this can take some time, and there were an example on the time it takes here to load up the scripts. Oops, it was before, I think. Yeah, so it has some examples on how long it takes to load up the script. However, once they have been loaded in the system, it doesn't matter the number of digits or strings in the that have been entered in the system, because it's all hashed and it quickly goes and finds the right number in the system. All right, so it doesn't affect call performance here. Oh, not this one. Where's my presentation? Any other comments or questions on label routing? If not, we will take a short break. 15 minutes. 15 minutes. Okay. So quarter past the hour, we will reconvene to continue, and I will explain the radius routing and the SIP redirect, and then we will show the call detail record information. All right. Okay. So 15 minutes. I'll meet you in 15 minutes. Any questions on the previous slides, which have not already been asked? Okay. So next portion of the routing is radius routing. So at some point in time, we had customers who had radio servers available. So they had their own radio servers, and they had processes inside those radio servers. So for example, East Coast routing, time of day routing, verification of user, and these types of applications. And they asked us to do a radius interface to those servers. So to make this work, we need an external radius engine that will accept calls and will return various parameters. For example, um, these types of information. Okay, then to make this work in the SBC, just as we have done for the black and white listing or for the label routing, is to enable this radius routing script in the main script that you have, and maybe adapt it to the radius server. So we do have some scripts which attach to specific radius server services like JRSoft and Alaris Labs. So we have pre-designed script that match with their radius server, and the information that is compiled in the radius request are incoming call parameters that are received from the incoming call. So you receive the incoming call, you have parameters in here, you fill specific radius parameters that the radius server can understand, because radius request has a list of attributes that you can use. And you fill this up, you send it in a radius request to the radius server, and then it does the work of checking if the call is a valid one, choosing a list of routes, maybe changing the call number, maybe deciding on a call duration of the call, maximum call duration, I should say. And all this information is returned in a radius response with specific parameters like accept or reject the call, the list of routes, the new call numbers for each of those routes, the call duration also for each of those routes. When the SBC receives all those parameters, it will take those parameters and apply them to the right configuration so that the outgoing calls can be made according to the list of routes that was received. Depending on a radio server, we may have to send different parameters here, and possibly the reception of data here is different as well. Usually for each of the radio server that we interface with, we have some attributes. Some of them we use well-known attributes from RFCs. And sometimes we use attributes that are described just between the SBC and the radio server. So to do this, we add a new dictionary. And this dictionary defines which parameters can be sent to the radio server and received from the radio server. So I will show you this. Is that clear here? Yes. Then you have the configuration of the radio server. You have one option here in the gateway section of the configuration that's called radius. You need to input the radius name. You need to input the destination IP address of this radius server. You need to put the UDP port for reaching the server. So for authorization, there are two ports that are well known. One is 1812, and there's another one. And then you have to choose the server type, because for radius, we support also accounting, which is used for call detail records. So you have to choose here authorization or accounting. There's also a secret password that is used to encode the information that is sent to the radio server, and it has to be set up here. But that's all the information you need to put there for the radio servers. You can have also more than one radio server. So you can just create a new radius authorization entry here with a different IP. And you can choose the priority amongst both of them. To use radius routing, you need to have the routing scripts. Like I said, we have some of those routing scripts which are standard depending on who you are interfacing with. So for example, with JRSoft, we will just give you the script that you need to use, and you will replace your main script with that one. In this routing script, you have 4 portions in the script. One is fill call attributes. One is, and the 3 others are for the answer. Okay, so the first one is for the request, so going from the SBC out to the radio server. And the 3 others are answers received from the radius server. Okay, so it can be either I reject the call. So then if we receive reject from the radius server, we will automatically drop the call. One thing that can be done here is select what is the termination cause we want to use. So here in the response, they can say, well, use a 601 or 602 or 603, and then we can drop the call with this specific error code. Then we have also on timeout. That means we never received an answer from the radius server. All right, so the answer never came, so that we will also drop the call, or we will continue the call depending on what you have input here. And then normally what you do is you have on accept. That means the call is accepted, and in this response you will get routing information, and that means usually proceed with the routing according to this routing information. Okay. So to fill the call attributes, one example is here. So the software code that looks like this. So the call number will be put in the parameter that's called called station ID. And the calling number will be put, okay, calling number will be put in the calling station ID. And then the other parameters like the network access point will be put in a generic value of authorization. So the ones that you see generic here are the ones that we defined ourselves between us and the destination. Us and the radio server, I mean. Okay, and then you have for each of those authorization requests, you can have a username and a password. Okay. Which mandatory auth parameters should be filled? Well, there's no real minimum of authorization parameters. However, by default, we see something like this, right? And the reason we have this is that these values are verified by the radio server. This information here is a session ID, so that identifies this call specifically. Right? So normally that is used by the radio server to identify which session was accepted. And usually you need to put a password and username. But the NAP here is not necessary. And the remote SIP IP, well, if the radius wants to keep it, we can send it. But it's really an understanding between the SBC and the radio server. Which information do you need? And we can fill it up as you need it. And actually, William now is working with a customer that we have, and he's creating this authorization request. And there's a lot of parameters. I think there's like 30 parameters that they need from the incoming leg. And so we just fill up all these values and we send it to the radio server. Okay, so in the response that is received on the accept here, we get routing information. If there is more than one route that is being returned and one of these route is not available, we will automatically try the other route. So the route retry processing is the same. However, it depends on what we receive here. If we receive just one route, then we will be able to, we won't be able to do what we try. But if it returns 2, 3, or 4 routes in, and it tells us the priority that they need to send these calls, then we will do that in order, and the route retry will work there. Now, I talked to you about the dictionary. So for example, you have some default parameters. So you see here, calling station ID is defined in one of the RFCs for radius. And I will talk to you about this in the next presentation that talks about call detail records. Okay, and so you see these are standard information, but others like generic are non-standard, and we can create our own. To do this, you can just create a new dictionary. And a dictionary looks just like this, or maybe I can just show you one that I have here. A radius dictionary is like this. So you see a generic TechObjects dictionary. So you see these are all comments, 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 comments. And then this line is important because this defines our value a dictionary number, okay? And it needs to be different from other existing dictionaries. Then you just put here your attributes, and the attributes is a name that can be used in the scripts, and a value, right? And a definition of the value. So here we use all strings. So it's a series of characters that is there. If the radius server detects that the attribute value is 1, then it knows it's a generic remote IP, and it will know it needs to extract a string out of this message. Okay. And this is just an example: trunk group name, truck name, local routing number, gateway name, reject reason, and then in this particular case, the radius server could return 4 routes, and we can try to make calls on each of those routes. Okay, so this is a sample dictionary. So it just has list of values, list of values that you have here. To make this work, you need to upload it to the SBC. So where do you go to upload it to the SBC is FileDB again, import new radius dictionary, and you can put it here. Okay, so you just do update after this if it changes. You also need to upload it to the radius server because it needs to know those same values here are matched by between the SBC and the radius server. And if you want to take a Wireshark trace of these radius packets, you can add this dictionary also in Wireshark to be able to decode those new parameters. Okay. Otherwise, you will not see them. You will see just unknown values in Wireshark. All right. So the dictionary has to be loaded in the SBC, in the radius server, and also in Wireshark. We have, if you need to use this, we have the procedure for you on the wiki, and we can point you to that on how to add the dictionary in Wireshark, I mean. Okay. And it's not more complicated than that. All right. So if you use, for example, the radius server JRSoft, so you need to purchase this radius server from JRSoft, and then we have a default script file that can be loaded in the system, and it will just work out of the box. Okay. If you have your own radius implementation, then probably we need to work together to make this work as you need it. So radius routing, once it's set up, radius server is configured, it's available. If you get a call in, it's going to send a radius authorization request and get the answer from there. So to be able to debug this, you would want to look in the call trace, because you will see in the call trace there was a message sent to the radius server, and you will see which route were selected for this particular call. And for example, if the radius server doesn't answer or something like that, you will also see that in the call trace. You can, as always, look in the call detail records. You will see each of the calls that were done in the system, if, of course, you have enabled this. In the NAP status, you will see if the calls were accepted, if the incoming call is working, and the outgoing calls. You can look at this. You can capture a radius trace. And there's 2 ways to capture this radius trace, and it depends on how you configured radius. All right. When you configure this, you need to decide from which interface you will be sending this radius information. So if you send it from the management interface, so remember, maybe yesterday I talked about a little bit about the management interface, which is not protected on the SBC and is running on the CentOS host. So then you need to use TCP dump to get the radius capture because it's using the CentOS management interface to send those messages. Or if it is using an IP interface, so a LAN WAN interface in the system, then you need to do a VoIP capture using TB router. And again, I showed you this yesterday. You select TB router, you press P to do the packet capture, and you will see not only the SIP and RTP traffic, but you will also see the radius traffic in there. It's very simple to filter out radius. If you have a capture, a radius capture, you can just do, well, this one is what I was already filtered out, but you can do radius like this, and it's gonna sort all the radius packets, and it's gonna check the port, right, 1813 or 1812, and it will show these packets, okay? And if you open the radius protocol, you will see the attribute pairs here and all the information about these values. And you see here, I see unknown attribute. Unknown attribute means that it cannot decode the dictionary. So I would need to load the dictionary, which is 50,001 in the system. Okay. Oh, maybe I can just show one more thing I saw here. You see access request and access accept. Okay, so access request is sent from the SBC to the radio server, and access accept means that the call was accepted, because it could be also access reject. So that's the other answer you can get from the remote side.
Yeah, I got the same audio issues. You're having a bit of digital sound, so maybe.
Oh. Yeah, you need to tell me. It happens sometimes, and I didn't figure out why yet. Give me a second.
Thank you.
Do you still hear me as a digital man?
Yes, it is still a bit digital.
Okay, give me a second. How about now? Do you hear me better?
Yes, sounds so much better.
How long was it bad quality voice?
5 minutes.
Oh, whoa.
I should have jumped in.
And I'm there talking and talking. I didn't figure out why this happens, but sometimes it does that. Okay. So what I was just saying is this trace here. The radius trace here shows if you can filter with the radius here in the for Wireshark, it's going to display only the radius messages. You can see here access requests. So this is sent from the SBC to the radius server, and then the answer can be access accept. That means the call was accepted. Or access reject means the call was refused. And then if I look here in the access accept, you can see some attribute pairs. And here I know that these are routes that were sent to me. And now actually you can see them down here, right? Because it's just a string. So it's a little bit small, but you can see that it is the call number and then the calling number with a 223 pound prefix. And then carrier 3 is one of the network access point that is being used in the system. And 2.2.2.31 is an IP address that we can use to route the call. And you see you have 4 routes like this in this particular trace, okay? Okay, and one thing I did not talk about in the routing scripts is when you want to debug routing scripts, you have the ability to print traces in the gateway log. So as I said, gateway is where all the routing script action takes place. And if you want to see what is going on, you can do a log trace like this. And you can select the trace level that will be displayed for this particular call, okay, or that particular trace. So if you put, for example, log trace level 4 in the script, in gateways at trace level 4, you will see those traces. If you put log trace level 1, here you will need to have these logs set up as level 1. But this is a good tool to debug a script because you can print information on each of these parameters that are present in the script. Okay? So I may show you that later. Okay. So you can do a similar type of system, but using SIP redirect instead of radius. All right, so this uses a SIP call to send to a SIP redirect server, and it returns some information about where to route the calls. The SIP call here, you need to fill the incoming call parameters, similar to what you do with radius. However, it needs to fit into a SIP call. So it can be header parameters that you change, or it can be special headers that you change in the SIP call. Okay? So they are not, it's not attributes like you have in radius. Then you need to configure a route in the SBC so that a call that comes in may go to the SIP redirect server if you decide so. All right, so maybe in some cases, all the calls need to be sent to a redirect server so that the routes can be chosen. All right, so you receive the incoming call, send to the redirect server. It will choose if it accept or reject the call. So instead of a 300 response, it can return a 603 or 503 or something like this, and the call will be refused. It will send us a list of SIP contacts. And then with this list of SIP contacts, we can decide how to route the calls here. Okay. You can also include more information in those SIP contacts, like the trunk group and other, call number and all these information. Right? When it returns this, then we choose how to route the call. One example of SIP redirect server is ClearIP that we talked earlier on. So then you can have a fraud call verification. So you receive a call here, you send some information to this fraud detection service, which is really just a SIP redirect server, and then returns an answer, which can be accept or reject. And we can decide on an accept to continue the call or on a reject to drop the call. So fraud detection is one implementation of a SIP redirect server. So if we look at just a little call flow here, you get the invite coming in from somewhere to the SBC. And then we send this invite to the redirect server. And here we can send it as is or modify some information before sending it out. The SIP redirect server can return various information, but one example is 302. You can receive a 302 with two contacts. And in this case, we can have the SBC make a call to this IP and this SIP contact. So we can do this. Sometimes instead of being an IP, it's a trunk group. So if you return a trunk group, we can then send an invite on a list of naps which are included in this trunk group. Okay. Lilip, you have to tell me how to zoom the Wireshark. Okay, what is a trunk group? A trunk group is a custom parameter, and it's actually a custom nap parameter that we can use to group naps together. Okay, so for example, if I put, let me go in a web portal here. Where's my web portal? I'm pretty sure I have an example, maybe here. Yes, exactly. Okay, so here I have an example of a trunk group. So here I called it trunk group out, but this, as you know, it's a custom parameter. So the script that will be matched to this trunk group needs to understand that this is a trunk group value. And here I have a trunk group out, and we have two vendors. So let's say these two naps are trunk group vendor 1, and all these other naps are trunk group vendor 2. So if the SIP redirect server returns us vendor 1, we can then route the call on both of these naps. And if they return vendor 2, we can route on all of these naps. Right? So this has another level of integration with a SIP redirect server. Lilip, does that answer your question for the trunk group? Let me continue here. Can we use, yes for now, okay. Can we use SIP redirect routing to check the call score from clear IP? Because we don't want to rely on the contact list given by clear IP. Correct. So the way clear IP works, it does not return a list of contact. All right, so it returns only accept or reject call. That's the only thing it returns. Well, it's not true. The first thing it returns is accept or reject. And the third thing it can do is please verify with the CAPTCHA server. So I talked to you about this a little bit. The CAPTCHA server allows you to do a call and verify in band if it's a real caller, right? So, but most of the time, the implementation we have seen, they use only accept or reject, and there's no list of contacts when they reject the call. Okay. Okay. Everything in there is optional, right? So we have a lot of flexibility there. Just one way of installing this. There's multiple ways of installing this, but the one that we use usually, and that the one that is described on the wiki, you have one NAP with proxy equal none. So that's an open NAP so that you can receive calls from anywhere. And then we will redirect this to the redirect server, and they will be checking if they accept the call instead of being the configuration of the SBC. Okay. And then the only other thing you need to do is add a new column that's called server type, and you call it redirect. The others, either you have nothing, or you can set a value of normal or whatever else. Okay, so when you receive a call, it will look for all the devices that are marked as redirect. So maybe you have a backup redirect server here, and so you need to configure redirect server type here, and the call will be sent to the first one and or the second one, depending on how you have configured it. When you get the answer, then you can route the call normally if it's accepted, and maybe use some other parameter to make the calls. Okay. And as I said, the script can be customized. So one example I know we have done recently is we added a SIP header parameter in the contact field. So for example, we have added the trunk group, and all naps with this trunk group value will be added to the list of routes. All right, so when we receive the contact field with trunk group, maybe TGAXEP like this, we will verify all the network access points which are marked as TGAXEP, and we will try to make calls to each one of them in order. And then to debug SIP redirect routing, it's very similar. I would start with the call trace, see if the call is being forwarded to the redirect server. You will see it here. You will see the answer, and you will see also the contact information in the call trace. Okay, so you will see which route were selected by the SIP redirect server if this is how you use it. Call detail records. Okay, you can see all the information there. You have the NAP status, as we explained before. In addition to this, since this is a SIP redirect, you can just capture a SIP capture with the application TVSIG trace, and you will see the SIP redirect request and the answer received from the redirect server. Again, gateway logs, trace level 1. So anything that is routing scripts, radius, redirect servers, gateway log, trace level 1 is a good idea. Then I have some examples for let me just find it here, SIP redirect. So you have an incoming call that came in as NAP TB lab, okay? So that's the name of the NAP. And there were calls sent here. And here I know that the first one was sent here, this invite, and this was sent to the redirect server. Okay, and the redirect server was called TMS lab. Okay, so you see this here, and you see the 300 response here. You can see the redirect contact that were input into this 300 message. So you can see what is the string that was returned. And I know for a fact that this particular script that we had done as a trunk group value, and then this trunk group value called, I don't know, vendor TG1 was meant to find vendor NAP1, vendor NAP2, and vendor NAP3 in our list of NAPs. Okay. And then what else is here? And then we see that we found 3 matching routes with those 2 values of vendor trunk groups. So it's going to try to make calls to each one of those destination. And in some cases, if there's no answer quickly enough, we will cancel it and try the next invite. And you see here, it's really 10 seconds 10 seconds before the call is canceled, okay, because we did not receive any 183 or 180. So that's the default route retry, 10-second delay here. So we wait 10 seconds for the first one, 10 seconds for the second one, 10 seconds for the third one. But then since we have no more route after that, then we terminate the call, and you can see that it returns a not found to the incoming leg. So you see also which information on each one of the routes. Also, you see information on the SDP here that is being used, which IPs are being received and sent. So you can usually debug a lot of things with this particular trace here. Also, you can remove, like you see, you have the red or green, I mean here, being sent to this destination, and you can just click on TMS lab, which was the green one, to remove that. And then you can see only some of these routes that were taken. So maybe I can remove all of them except the blue one. All right. So now you see the incoming and the blue only, vendor nap 3. And you can actually hide all of them. Okay, so the SIP redirect trace. Then Lilip told me that if I go in view and I want to zoom out, let's say normal size, zoom out. Oh, it's control what? Control minus. Let me try that. Control plus. Ah, there you go. Thank you, Lilip. Okay, so here I can see, for example, the call that came into the system. Invite. Oh, no, actually, that's the call being sent out to the redirect server. So we don't see the incoming leg here, only the outgoing leg. So we see the call being sent out from the SBC to the SIP redirect server. And then we see the 300 redirect with information on the contacts here. So you see the contact information, but you see we saw the same thing in the call trace. So you don't necessarily have to look at this trace here if that's the only information you are interested in. And then you see that we try to make calls to each one of those contacts. So here you just see an IP address. So sometimes it's better to look in the call trace to see where it's trying to send this call, which makes more sense than just an IP address. Okay, but here you have all the packets and all the information from the SIP trace here. And there we see it tries to send to the first destination, but there's no answer. And then it goes to the second destination. Okay. And finally, oh no, it goes just to 2 destinations in this case. Okay, so this is the SIP redirect trace. And then let me show you just briefly the script. So, yep, DTG. So that's the script that was used to make this test. When we do a special script for a customer, We usually try to put enough comments here so that it makes it clear what you need to do. So normally there's a little description on what we want to do and the instructions on how to install it in your system. And as usual, as you saw with the black white listing and the label routing, you need to do require, include, and add a filter. Okay, it's just the name here that change depending on the functions you are using. Here, in addition to this, we have additional information that we need to configure. One is a nap column with name server type, which will tell us if it's a redirect server or not. Another nap column with tgin, because we send this information to the redirect server, and a tgout means that the information that is returned from the SIP redirect server, we can use it to choose the outgoing naps on our systems. Okay, and this is the script per se. So there's some information here. Get the call information, get the nap list, get the incoming nap, and there's a few tricks here. And here I told you there is the function that's called log trace to print traces in gateway application. And you see here trace level is defined here. And then you can just put some text like this. So you put quotes and you put text, it's just going to display stuff in the routing script. And you can display parameters by using the inspect command. So this is a command that will show what this parameter is. So if it's a string, it's going to display a string. If it's an integer, it's going to display an integer. If it's a hashing table, it will display the hash table. Okay, so it's interesting to use this function. And you see I use it a lot. Parameters inspect, call inspect, nap list inspect, and you can change all of that. And that's the rest of the script is defined here. Okay. And the question is, are all scripts in ProSBC written in Ruby? The answer is yes, they are all written in Ruby. However, sometimes it links to or functions that are built in C or C++. Okay, so when you do a radius request, for example, the filling of the parameters is done in the Ruby script, but then when we get out of this function, it goes to a C++ code, creates the radius request and sends it and makes sure it reaches the destination, does the retry and everything. All of this is written in C++. So of course, more efficient than what you can do in Ruby. Yes, yes, of course. Yeah, and it's actually well, you need to have done some programming, of course, to be able to be familiar here. But I am not a Ruby programmer, but I learned it by trial and error, and that it's fine, right? And I can just create some scripts using the Ruby programming language. I usually use examples that were done by programmers and I modify them, right? So it's usually pretty simple to do that. And if you're looking for a specific function, well, you just search on the web, right? And you will see how to split a string in Ruby. And it will, you know, you have hundreds of examples how to split a string, and you just use those functions in your script. So very open type of interface here. Right? Of course, when you do a routing script, you need to be careful because the script that you do affects all your routing. Right? So if you make a mistake in the script, your calls may not be routed anymore. Right. So if you drop a call in the middle of your script, then the call will be terminated. So you have to be careful, and you need to have a good test plan designed after you have done your routing script, so that it will work in all cases. Can the SIP redirect server be like Asterisk or other SIP server? Absolutely. It can be anything here, right? Anything that can get a SIP call and answer something, either an error code or a 300 response, can be used as a SIP redirect server.